Hi all, I'm Shreya. So this is a short video about my midterm project. The project is on is building a cloud-based PE Malware Detection API. So this project has three tasks. The initial task is training the model with the Ember dataset. So here is the Ember dataset GitHub link. So this is the GitHub repository for the Ember dataset. So you can download the Ember dataset from these URLs and install all the required Ember libraries or packages from using these lines of code. So and then in this task, after building a model, we are just testing it by giving a random PE file to the model and seeing whether it returns a correct output or not. And the second task of this project is deploying the model to the cloud. For this, we are using Amazon SageMaker service. And the third task is creating a client so that any others can use this API. So let's get into the first task. So this is my this is my notebook file for the task one. So this is a self-explanatory notebook file. So it has a bit of text in front of each and every block of code where it is needed. So we are basically downloading the data set here. And cloning the GitHub repository here. And this block of code takes a lot of time to run, so be patient. It basically vectorizes the features and gives a metadata file, and this block of code it converts a metadata into data frame. And this divides the data set into four parts. So the training and testing, training features and label, and testing features and label. So totally four files. We all know about the Ember dataset, right? So it has 900k. The training set has a 900k samples, and the testing set has a 200k samples. So let's come to the data preprocessing. So we know that the Ember training set has three categories. So those are unlabeled, benign, and malicious. So I don't want to use unlabeled in my project. So I just removed those rows which are considered as unlabeled samples. So this the all this block of code does the same. So you can see that if you execute all this till now, the RAM gets crashes and you cannot move further. Again, you have to repeat the process there, which is like a loop. So what I did is after creating everything, and I have pickled all these files, all the required files, all the dataset files. So and then upload it into my G drive. You can connect to the G drive by using this sample of code. So here I'm uploading to my Google Drive and I'm reading from the Google Drive. But I see that even then the RAM crashes because the pickle file size is not that great. So I found an alternate option, which is using H5PY library. So the same process, converting the dataset into the files, and then uploading it into the Google Drive and then reading from it. So the features, I want to standardize the features to this. I want to scale the features, precise to say. I want to scale this feature, so I have used the different scalars like standardized scalars and min-max scalars and rubber scalars. Out of those three, I found rubber scalar is much more efficient, so I've used it and then converted the data set into H5 file and then uploaded into the Google Drive. Reading from it, did the same. If you observe, I have printed size of the loaded data from the pickle file, from the serialized files, to see whether each and every sample is getting reloaded or not. You can do a bit of testing like that, and then the next comes the main part, which is model architecture and training. I have did a lot of hyperparameter tweaking and finally built a model. Basically followed a few of the deep learning, norms. Yeah, while building the simple dense layer model. So I've used dropouts, I've used reactivation functions and optimizers and all. So this is a simple model which doesn't result a high performance. So my model has given a performance of 51% for a one epoch with a batch size of 256 and around the same for 30 epochs with the same batch size. And I have also split the train data set into two parts, 80-20 split for the validation data set. So you can do or you cannot do, it's up to you. So I have the testing accuracy that I have obtained is 44%, which is fine for me. And then we have to save the models to deploy it into a cloud. So I've saved the weights. And if you see here, I even saved the entire model also in this line. And then I'm also saving my model into a JSON format. So here I'm downloading an Anaconda API file to the collab and checking it as a post-training check. So after running this piece of code, you get this. So the final result is 0, which is nothing but a benign sample. Obviously, Anaconda executable file is a benign one. Okay, this concludes the task 1. Okay, let's move on to task 2. So for the sake of task 2, you need to have a AWS account and SageMaker access. So you need to create a notebook instance and open the Jupyter, which looks exactly same like an Anaconda Jupyter server. So I basically followed the resources that were given for the task 2, which is a video and a Jupyter notebook. So the video has a good explanation of what each block of code is for, but I'll give a vague explanation of each. Here, in this block of code, we are getting a role that was assigned to the SageMaker and then importing the required libraries. So we are creating a folder to upload our model files. After uploading here, I have uploaded my model weight files and the model in JSON format file to the SageMaker. And then here we are loading it to a load model variable. And then in this part, we're loading the weights of the file, of the model. And then to export it into cloud, it needs a proper path that starts with export and servo. So we are doing that. Basically, create a folder called export, and then inside export, create a folder called servo. And inside servo, create a folder called 1 because this is the model version 1. I've just followed whatever that was given in the resources to do this. So this block of code, it basically removes all the files in the directory. And then these are all the internal structure of that. So here, when you come to this code, here we are like connecting to the SageMaker. We are creating a reference to the SageMaker to deploy the model. And here we are deploying the model. And to deploy the model, it took me around 8 minutes and 32 seconds. So after deploying the model, the endpoint is created to the model. So take that endpoint and store it because you can use this endpoint without referring to all this process, all these things in future if you want to use this model particularly. Okay, I'm sorry for this. So let's see. So we have finished task 1 and task 2, and let's go to task 3. Task 3. Let me load the file up. So this is the Python code that I've created. So we are just passing the PE file in the file, executing the file in the command prompt, and then here we are connecting it to the SageMaker. So basically, you have to give your IDs from AWS CLI. Once you execute this code, you get a result whether it's a benign, or whether the sample is benign or malicious. So let me show you that. I have did this in two ways. The initial way that I want to show you is in a Jupyter notebook, because executing the related libraries and packages in a local computer is very hard or tiresome. I can say that. So I have first tried it in the collab Jupyter notebook and executed it. If it is working fine, then I've tried in my local system. So you can see you can execute all those things which we did in the task one also. So it basically imports the packages required for the Ember methods to run. So here now I've downloaded the Anaconda exe file, which you can see here. Sorry, it has downloaded multiple times. So if I execute this file, I'm gonna get a result as a benign, because obviously Anaconda is a benign file. So I want to show you that, because this is my final execution, which is what I built the project for. Okay, while it is executing, let's do this um, in the command prompt. Okay, so I already have a sample here. So all my files are in the Ember folder under my username. So I've gone to the folder, and then now I'm executing the file. So here you can see the execution is quick, because it has all built-in packages and all, and more. So the execution is quick and easy. So let's see what's going on in the previous execution. Okay, it is still running. So while it runs, I want to show you my project report that I've made. So this is the project report. It has all the details written very clearly, along with the images of the code, and why I did that, what I did, and all. If you have any doubt if you didn't understand anything that I've explained so far, and if you want to know more about it, you can just refer this, which is available in my GitHub repository, and you can find the link of this below. So let's see what's happening. Oh yeah, we have the execution is done, and the final result is benign. So I can say that the project is successful, and I have learned a lot about a lot about a lot about the would you say requirements to build a project, and how to do it, and how to overcome errors or issues that gets arises while doing it. So this is very knowledgeable and worth working on. Please do try this, try to build this project. Thanks for watching my video.